This video is going to cover solving these 14 questions from the trig equations worksheet. All of the answers are going to be given in degrees. Okay, so for number 1, the question is the cosine of theta plus 1 equals 0. Okay, so the first thing you need to do is we need to solve this equation for cosine of theta. So I'm going to subtract 1 from both sides, and I end up with cosine of theta equals -1. Now, if you recall, what we can do here is we could use our unit circle. Remember, when we solve cosine, we're going to look at the x of our ordered pair. So I'm looking for an ordered pair where my x value equals -1. Now, if you look over here at your unit circle, there aren't any coordinates along here, here, or here that have a -1 in the x value. But I can look at my axis points and notice right here I have an ordered pair where x equals -1. So the answer for theta for this problem is going to be 180 degrees. Let's try number 2. Number 2, the problem is sine squared theta equals 0. In order to solve this, I'll square root both sides, and I end up with sine of theta equals 0. There's not a plus minus 0, it's just 0. So here, I'm going to go ahead and for sine, if we're going to use the unit circle, sine, we're going to look at the y of our ordered pair. And I'm looking for a y value that's equal to 0. So if I come over here to my unit circle, let's look for this one, and I'll highlight this one in red. And you can see that you have a y value here that equals 0 and another one over here. Now, recall on your unit circle that this ordered pair is associated with 0 and 2 pi, or 0 and 360. This one is pi and 180. However, all of the questions that we're going to be answering are going to be from 0 to 360. 360 has a parentheses, so I'm not including 360 in any of my answers. So the only answers here for this problem for theta equals 0 degrees and 180 degrees. Let's try number 3. So for number 3, the problem is 2 cosine theta minus root 3 equals 0. I'm going to add root 3 to both sides. 2 cosine theta equals root 3. Divide by 2. Cosine of theta is equal to square root of 3 over 2. Again, we're doing cosine here, so we're looking for an x of our ordered pair that equals root 3 over 2. Now, let's go ahead, instead of having to look at the entire unit circle, let's go ahead and do our all students take calculus. We need to find out where cosine is positive, and I can see that cosine's positive here and here. So I'm going to be looking at my ordered pairs to see where x equals root 3 over 2. So let's go ahead and I'll highlight this in green. So let's zoom in on my unit circle here. And you can see that right here, this ordered pair and this ordered pair. These are the two order pairs from quadrants 1 and 4. So my answer to this problem is going to be 30 and 330. So theta, so 30 and 330. So theta equals 30 degrees and 330 degrees. Now, another way that I could have also solved this is I could also use my triangles like we did back in chapter 5. You could also use your sine and cosine graphs. However, let me go ahead and draw a triangle here. 30, 60, 90. Now, this is the way that you can do this if you don't want to use the unit circle. Remember, the side across from 30 is 1, across from the 90 is 2, and across from the 60 is root 3. Now, if you're going to use the triangles, you have to figure out, is your reference angle the 30 or is it the 60? So let's go ahead and label the sides based on the 30 degree as my reference angle. So this would be the side opposite, this would be adjacent, and this would be hypotenuse. So if I'm doing cosine, remember cosine is adjacent over hypotenuse. So let's say I'm going to try and test out to see if the reference angle is 30. So cosine of 30 would be adjacent over hypotenuse, which is what I was looking for. So my reference angle is 30. Remember, to get the angle from quadrant 4, you do 360 minus that reference angle. So 360 minus 30, and that's how you get the 330. So you can also draw triangles if you don't want to use your unit circle. The first two problems did not involve triangles. Those were from the axis points. Okay, so I just made a new page, and now I'm going to work on number 4. So for number 4, the question is 2 sine of theta plus square root of 3 equals 0. I'm going to subtract the square root of 3 from both sides. 2 sine of theta equals negative root 3. Divide by 2. Sine of theta is equal to negative root 3 over 2. Again, remember, sine looks at y. So I'm looking for a y of my order pair to be negative root 3 over 2. I need to narrow down my quadrants that I'm going to inspect. All students take calculus. I need to find where sine is negative, and it'll be negative here and here. So I'm going to look at my y's to see where it's a negative root 3 over 2. So if I come over here, I can see that it's going to be at this order pair, which is 240. And then it's also negative over here, and that's 300 degrees. So the answers for theta are going to be 240 and 300. Now I could also draw the triangle here and figure out which is my reference angle. So again, have your triangles drawn. 1, 2, root 3. Remember, sine is going to be opposite over hypotenuse. Now, I can already see my reference angle is 60. So let me go ahead and just set up my angles in relation to the 60. So this is opposite, adjacent, and hypotenuse. So sine of 60, opposite is root 3, hypotenuse is 2, and again, we were just looking to see the quadrants where the 60-degree reference angle was negative, which was quadrants 3 and 4. So either way, either have a unit circle handy, already filled out, or you can also solve these like we did in chapter 5 by using the triangles. Okay, so let's try number 5. 5 has 2 plus secant theta equals 0. I need to isolate secant theta. Secant theta equals -2. Remember that secant is the reciprocal of cosine. So I'm going to change this to cosine and then flip it to the reciprocal. The sign stays the same. So again, if you're going to use the unit circle, cosine looks at x. So I'm looking for an x to be -1/2. Let me go ahead and do my all students take calculus. And I'm looking for cosine to be negative. Cosine's negative here and here. So again, I'm going to go to my unit circle. And I'm looking for an x value that is -1/2. So right here, and then right here. So my two answers for theta here, theta is equal to 120 and 240. Again, you can also do the triangle. 30, 60, 90, 1, 2, √3. My reference angle here is the 60. So opposite, adjacent, and hypotenuse. So cosine uses adjacent and hypotenuse. So 1/2, which is what I was looking for. So you can see that your reference angle here was the 60 degrees. And if you're doing the triangles, over here it would have been 180 minus the reference angle, and here would have been 180 plus the reference angle. So again, you can solve these either way. Let's try number 6. Number 6 has tangent of theta times cosecant theta plus 2 equals 0. Notice this one is already factored for me, so I just take my two factors, set them equal to 0. Now this one. Tangent theta equals 0. That one's already finished. Let's go ahead and finish this one. And again, cosecant, this is going to be the reciprocal of sine. Flip it to the reciprocal. So now it's -1/2. So for this one, sine, we look at y. So I'm looking for a y that's -1/2. Let's do our all students take calculus. And I can see that sine will be negative down here. So I'm looking for an order pair that has y equal to -1/2 in these two quadrants. So my y, where it equals -1/2, are going to be here at 210, and then also at 330. So theta from the unit circle is going to be 210 and 330 degrees. Now if I come over here and do tangent, let me do this in green since I've already highlighted a blue. So for this one, it's going to come from the axis points, because remember, tangent is going to be y, tangent of theta equals y over x. So I need to figure out which order pair. When I divide y by x, I get a 0. So automatically we know that the y has to equal the 0. The x didn't matter, so the x is just a number. So this would be the order pair from the axis points. Let me go over here and highlight it. It's over here. I'm looking for a y to be 0. So this answer for theta is going to be 0 degrees and 180 degrees. So the answer to number 6, it's got 4 angles. It's got 0, it's got 180, 210, and 330. Now, for this one over here, the green, you can't use a triangle, but for the red, we could have drawn a triangle. So 1, 2, √3, and again, we could try to figure out what our reference angle is. It's actually going to be the 30. So this is opposite, adjacent, and hypotenuse. So if I'm going to do the sine of 30, that's opposite over hypotenuse, so 1/2, and that's my reference angle. So my reference angle is 30 degrees, and again, to get a quadrant number 3, you take 180 plus the reference angle, and that's how you get 210, and then 360 minus the reference angle, and that's how I got the 330. So that's how you got those two answers if you were doing the triangle. Again, if you've already got the unit circle, it's a lot faster. Remember, cosine looks at x, sine looks at y. Okay, let's try number 7. Number 7 has cosine theta times tangent theta minus √3 equals 0. So again, another problem where it's already factored for us. So set each of the factors equal to 0. So this with this. And then now we can do this one with this. So tangent theta minus √3 equals 0. So the first one's already solved. So what we're going to do is we're looking for an x value equal to 0. So again, that'll come from the axis points. So we're looking for x equal to 0, and that's going to be here and here. So 270 and 90. Now for the blue, let me go ahead and finish solving it. So I'll add √3. So again, tangent of theta is y over x. So I need to figure out which order pair will give me √3 when I divide them. And that's actually a reference angle of 60, because that order pair is 1/2 √3 over 2. And if I divide √3 divided by 1/2, which is multiplied by the reciprocal, I get the √3. So This order pair goes with the reference angle of 60 degrees. So again, I can do my all students take calculus. And I know that tangent is going to be positive here and here. So 60, and then what we can do is come over here, and we're doing 180 plus 60, and we get 240. So the two angles for this are going to be 60 degrees and 240 degrees. So your four answers are 9270 and 6240. Now, we could also do a triangle for this one. 30, 60, so 1, 2, root 3. So now, again, you need to figure out, is it tangent of 30 or tangent of 60 that gives you root 3? So again, if we do tangent of 60, let's label the sides in relation to the 60. This is opposite, adjacent, and hypotenuse. So if I do tangent, which is TOA, opposite over adjacent, opposite is root 3, adjacent is 1, simplifies to root 3. So that tells me my reference angle is 60. Possibly for the tangent, it might be easier to draw the triangle. Again, it's totally up to you. All right, let's try number 8. Number 8 has cotangent squared theta plus cotangent theta equals 0. For this one, I'm going to factor out a greatest common factor of cotangent. So once I factor out a cotangent theta from each one, the first is left with cotangent and then cotangent. So this one, when I divide it by this, I get this, and then this divided by this one gives me just a 1. And now I'll set each of my factors for number 9. All right, number 9, the problem is cosecant squared theta plus 2 cosecant theta equals 0. This one, again, I'm going to factor out a greatest common factor. My GCF is going to be cosecant. So out of the first term, I'm left with a cosecant, and out of the second term, I'm left with a 2. Again, now set each factor equal to 0. First one's already solved. Second one, I need to move the 2 over. Remember, cosecant is the reciprocal of sine. So I'll flip that -2 to its reciprocal. Now, over here, this should be a clue that, remember, the values for cosecant have to be greater than 1 or less than -1. So this one is no solution. If you were doing this on your calculator, you would see that you would get an error. You could also look at your cosine graph and on your sine graph, and you could also see that there's no solution there. So let's go ahead and do this one. So again, sine for this one, we're going to look at y. So we're looking for a y on my unit circle to be -1/2. All students take calculus. I want sine to be negative, so it'll be here and here. So if I come over here to my unit circle, I can see my answer is going to be 210 and 330. So 210 and 330. This one only has 2 answers because the first factor gave us no solution. Again, I could draw the triangle 30, 60, 90, 1, 2, root 3. And again, if I use my reference angle, you're going to see that it's the 30. So opposite, adjacent, hypotenuse. We're doing sine here. So sine of theta uses opposite and hypotenuse. And we're going to get 1/2. And then just adjust it based on the quadrants. Let's try number 10. Number 10 has tangent squared theta -3 equals 0. Add 3. Tangent squared theta equals 3. I need to square root both sides. So tangent of theta is equal to plus and minus root 3. So once I figure out my reference angle, it's actually going to be 4 answers because of the plus minus. Don't forget, when you square root something, you need to put both the plus minus. So tangent, remember, is y/x. So if you're using your unit circle, you need to figure out which order pair, when you divide the coordinate, will give you square root of 3. So if I take the order pair 1/2 root 3/2, and if I divide y by x, change flip here, you can see that this order pair gives you the root 3. This is a reference angle of 60. So here, all students take calculus. My reference angle here is 60. I can do 180 minus 60 and get 120. 180 plus 60, get 240. 360 minus 60 and get 300. or. So that's doing it that way. So my four answers here are 60, 120, 240, 300. If you don't want to go through the process of adding and subtracting from the 180 and the 360, the other way is to go over to your unit circle and find all of these order pairs. So I'm looking for this one. I'm looking for the 120, this one, and this one, and this one. So again, you could look for this order pair from each quadrant. So that's number 10. Let's try number 11. All right, so number 11, let me go over here. So number 11 has 1 minus cotangent squared theta equals 0. This is the difference of two squares. So I'm going to factor this into 1 plus cotangent theta and 1 minus cotangent theta. I'll set each factor equal to 0. I'm going to move the 1 over. Cotangent theta equals -1. I'll just add the cotangent so it stays positive. This is cotangent theta, cotangent theta. 1 equals cotangent theta. So again, if you remember, whenever you see cotangent or tangent equaling 1 or -1, this tells you that your reference angle is 45. So again, I need to, because I have it both positive and negative, I'm going to be looking for all of the denominators in my unit circle that have a 4, or again, you could do the 180 minus 45 and get 135, 180 plus 45 and get 215, and then 360 minus 45 and get, this is 245, 225, sorry. It should be 225, and this is the 315. So again, you could look at the unit circle, and let me go ahead and I can show you how we can use that reference angle. We're looking for all of the denominators that have a 4. So that's another way you can use the unit circle. So that's number 11. 3 more. Let me add another page and add another unit circle in. Okay, so let's try number 12. Number 12, we have 2 cosine theta cosecant theta equals √3 cosecant theta. So the first thing I need to do is set it equal to 0. So let me move this over. So 2 cosine theta cosecant theta minus √3 cosecant theta equals 0. So I'm going to factor out a greatest common factor, and that's going to be cosecant. So once I divide the first one, I'm left with 2 cosine theta. And the second one, I'm left with √3. I'm going to set each of my factors equal to 0. And now this second one. So 2 cosine theta minus √3 equals 0. add the root 3 to both sides. 2 cosine theta equals root 3, divide by 2, cosine theta equals root 3 over 2. Now, again, the red one, remember cosecant has to be greater than 1 or less than -1, so this is no solution. For the blue, cosine's going to look at x, so I'm looking for an x equal to root 3 over 2 if I'm using my unit circle. All students take calculus. I'm looking for where cosine is positive. Cosine's positive here and here. So if I come over to my unit circle and I look for x where it's equal to, the x equals root 3 over 2, I have it here at the 30 and at the 330. So here, 30 and 330. So this one only has two answers, 30 degrees and 330 degrees. Now, again, you could also draw your triangle for the blue. 30, 60, 1, 2, root 3, and again, cosine, let's do it based off the 30, opposite, adjacent, hypotenuse. Cosine of 30 degrees is adjacent over hypotenuse, so adjacent is root 3 over 2, which is what I wanted, so that tells me my reference angle was 30. And then I put it into this, and I still get the same answers. Let's try number 13. Number 13 has 2 sine of theta, secant theta equals secant theta. I'm going to move the secant theta over. So my equation's set equal to 0. Factor out a greatest common factor of secant. And then what remains is 2 sine theta minus 1 equals 0. Set each of the factors equal to 0. 2 sine theta minus 1 equals 0. For the red, you should realize that secant has to be greater than 1 or less than -1, so no solution there. For the blue, I can solve. 2 sine theta equals 1, divide by 2, sine of theta equals 1/2. Again, sine looks at y. I'm looking for a y in my order pairs to be 1/2. Let's narrow down the quadrants. So sine is going to be positive in quadrant 1 and quadrant 2. So let's go ahead and highlight this in red. So over here, if I come to my unit circle and I'm looking for y to be positive half, right here and right here. So 30 and 150. So my two answers are 30 degrees and 150 degrees. Again, you could have also drawn the triangle. 30, 60, 1, 2, root 3. Sine of 30, opposite over hypotenuse. 1, so this is opposite, this is hypotenuse, that would be adjacent. These are in relation to the 30, 1 over 2. And again, you would have done it up here. Remember, this was the reference angle. This was 180 minus the reference angle, and that's how you get the 150. One last example, and this is a trinomial. Once we set it equal to 0, you will have this on the quiz. So let's go ahead and solve this one. 2 cosine squared theta minus cosine theta equals 1. I need to set it equal to 0, so I need to move the 1 to the other side. And now I have a trinomial that I can factor. So this will actually factor into 2 cosine theta. And then I'll put a cosine theta here. And then the factors of -1 are going to be 1 and 1. Put a plus sign there. Quick FOIL it, make sure it goes back. Outer gives me -2. Inner gives me 1 cosine theta. When I add them, I do get the middle. So now I can take the 2 factors, set them equal to 0. Move the 1. 2 cosine theta equals -1. Divide by 2. Cosine theta equals -1/2. Let me solve this one. Cosine theta equals 1. Now this one, again, cosine looks at x, so I'm looking for an x equal to 1/2. And then here, cosine looks at x, I'm looking for an x value equal to 1. This one is going to come from the unit circle. This one's going to come from the axis points. So my axis points here, I'm looking for an x to be 1. It's only over here, which is 0 degrees. So theta here equals 0 degrees. This one, I'm going to go to my unit circle. All students take calculus. I'm looking for cosine to be positive, so it's here and here. So then from here, actually it's negative. Go back. There should be a -1/2. So it's over here and here. So I'm going to go up to my unit circle, and I'm looking for an x value to be -1/2. So if I come up here to the unit circle, I can see that it's going to be here at 120 and 240. Come back down here. 120, 240. So the 3 answers to this problem are 0 degrees, 120 degrees, and 240 degrees. Now, we could also have done our triangle, 30, 60, 90, 1, 2, √3. If I'm going to be doing cosine of 60, because that's going to be my reference angle. So based off the 60, opposite, adjacent, hypotenuse, cosine is adjacent over hypotenuse, which is 1/2. So that's how I knew my reference angle was 60. Now, again, if you didn't realize that, then you'd also test out the 30 and see which one works. So now, when you're doing this on the quiz, you can choose. You don't have to do both the triangle and the unit circle. You can choose which way you prefer to do these. Again, have your triangles drawn, have your unit circle. If you want to if you're going to use the triangle method, I would already have the angles that come from the quadrants based off each reference angle already completed for you. Again, it'll save time. So the quiz is straightforward, it's linear, it's factoring GCFs and factoring trinomials. There will be no identity substitutions.